we talked about a little bit about the mechanism. So cryptocurrency uses digital encryption and the system of money. The genesis of cryptocurrency lays, as I mentioned, in early 90s with David Chaum launching DigiCash, and other guys like Hal Finney, Nick Szabo. For example, launched in 2006 the BitGold currency. Use cases for cryptocurrency: protects privacy, protects integrity, authentication, non-repudiation, which is once a transaction has been committed, it cannot be reversed. Okay. I'll leave you to read this about the codes and the MD5 and RSA. I'm going you to read this. You are going to do hands-on demo with Juliana, definitely. There are some inefficiencies with blockchain. One such drawback is the cost, because it takes a substantial amount of energy and power to maintain the blockchain under Bitcoin. Okay. In the notes, I put some calculations about how much energy it consumes. Okay. Reputational trust. It's hard to mine. Okay, so you have to invest also in equipment. It's not only the cost of operation, it's also cost the equipment. You need to have very performant CPUs. Graphic processor units are mostly considered. It is complex. There is a lack of understanding about blockchain technology, so definitely you will not expect a citizen of 70, 80 years old to understand blockchain and to invest his fortune in Bitcoins. Okay. There is also the risk of the 51% attack. If by any chance some data centers in Siberia and Alaska agree to cooperate together and take over 51% of the network, they could manipulate some of the transaction. They could, in theory. Another issue is with the regulators, because the governments, they don't like Bitcoin. They would like to introduce rules. However, in order to introduce rules, they need to understand what blockchain and Bitcoin are. And the problem is that there was such an initiative in the United States, in New York City. The government started to regulate. After the regulation was put in place, the guy who made the regulation resigned, and he created a private company to consult businesses about the regulation he had devised. So this is kind of unfair. Okay, not very nice. So regulation is an issue. Okay, there is a problem with real times because it takes, like, let's say 10 minutes to consider that the block is repudiable. It cannot be turned back. However, there are certain companies working on this. There is also a Romanian company. I don't have here with me the name of the guy who can make it in terms of seconds. So a guy who developed a technology to accelerate a lot the validation of the transaction. Okay, so that's it for today. The material I'm giving you is much longer, but it's a good introduction, I would say. So now you are aware about blockchain and Bitcoin. Guys, let's take 5 minutes recess. Meantime, I need to see if Andu, my guest, was able to join us. Let me see what happened. So 5 minutes, please.
Hi, Dan. I'm everybody.
You are in the, okay. Andu, then during this recess, you can take over the screen. Let me know if you can do it.
Gladly. Let me give it a try.
Go ahead.
I also have a faint echo when I speak. Does it also happen to you?
No,
now it's gone.
we hear you loud and clear, so don't worry.
Perfect.
Maybe it's from my device here. I don't know.
No, now it's all good. Now it's all good. No worries.
Okay, good. So will you try to put the slide deck on the screen?
As we speak.
Great.
Please let me know if you can see my screen, and please let me know if it's the correct one, if it's the presentation mode and not the...
It is the presentation mode, yes.
Excellent, many thanks.
Okay, so Andu, we are going to start around 5 minutes past 5, okay?
No, that's perfect. I also joined at the beginning. I really like your lecture, so
thank you.
Very informative. To my shame, I live less than 50 kilometers away than from something that's called the Crypto Valley. So
really?
the Silicon Valley might be in Western United States, but the Crypto Valley, it's actually in Switzerland. It's the city and small canton of Zug.
Because Switzerland is the country of the banks, so this is where it should be.
It's also the country of technology, it's also the country of cheap energy, and it's also the country of very, very safe places to hold data centers.
Excellent, yeah.
So I'm here online. Just let me know when we need to start.
Yeah. Let's wait another 2 minutes.
No rush.
We need to stretch the legs, to drink some water, and then we start. I'll let you know.
Sure. Take your time. Thank you.
So, hello everybody, welcome back. It is my pleasure to introduce my friend Andu Dimofte. Andu was a colleague with me in Oracle, but a few years ago he moved into Switzerland to work still for Oracle there. And he's specialized. He was specialized in big data. I don't know for now, but definitely it's a great pleasure to have him in our session here. Actually, Ando helped me with the second edition of this course, which was probably 4 years ago before moving to Switzerland. Yeah, and today he's going to tell us what are the opportunities Oracle is offering for big data in cloud. Andu, you have the floor.
Many thanks, Dan. Can you hear me well?
Yes, sir.
Great, many thanks. So as I was just saying, even though I'm currently living less than 50 kilometers away from Crypto Valley, canton of Zug, where the Ethereum Foundation is located, I actually learned a lot from the course, from your previous course. So it was a pleasure, and yeah, many thanks for the opportunity, giving me the opportunity to tell you some things which I learned myself in the last years working with Oracle. So I mean, you already gave me a good introduction. I'm Alexandru Andu Dimofte. I've been working at Oracle for 7 years now, until 2016 in Bucharest, where I had the pleasure to meet Dan, and since 2016 in Switzerland, focusing first on big data and data platform solutions, and now having a broader focus on the general Oracle Cloud. Just a thing, right? This is something that we at Oracle like to show. It's a safe harbor statement, and it says that, well, this is a presentation. It's correct to and up to date to my best knowledge, but companies always want to be covered, right, legally. And there is also a personal safe harbor statement, and that means that even if I'm using Oracle logos and Oracle materials, these are put in a way that show my understanding and my opinions. So this is not an official Oracle presentation, but my understanding and my message to you. Also, I mean, I was just thinking, right? Why should you listen to me? What do I want to tell you in this hour that we have together, or less than an hour? So my main points would be, first of all, what is Oracle all about? Then big data, right? What is big data all about? You already know that, but probably I won't tell you anything new here. But then what does Oracle have to do with big data, right? How they tie together? Then I'm going to go to cloud. How is cloud changing everything? Then a couple of case studies. And then also, I mean, Dan asked me to give you a hands-on experience, to give you a tour or a demo of what it looks like in the Oracle Cloud. I'm a bit conscious of the time. I see that there's a lot of points on the agenda. I will also try to do the hands-on demo, but best case, I will show you how you can go and register to Oracle Cloud yourself, how you can have a free account, how you can have access to demos and guided examples that you can do in your own at your own pace. So at least at the minimum, we'll do that. I'll show you where to go, how to get access to Oracle Cloud, what's available for you there, and how to get started on it. So what is Oracle about? I can actually, if anybody wants to tell me what they think when they hear Oracle, please just unmute yourselves and let me know if you can unmute yourselves. All right, for the sake of time, I'll go to what I supposed, what everybody thought, right? The first thought in the minds of most people when having this question. Oracle is about the database, right? Oracle is the database company. And that's, I would say that's mostly true. Oracle is about the database and many other things, right? Oracle has Java. Oracle is developing a very fast virtual machine, which is called GraalVM, and it's a multi-purpose one, right? It supports multiple programming languages. Oracle also it has a very successful Linux version. There's the Oracle Cloud. There are the Oracle applications. There is MySQL. There is hardware and many others. But the database, that's I would say a pretty good answer when thinking about Oracle. A pretty good first answer. And just to show that, a couple of years ago, Oracle chose a new corporate mission statement, which focuses on that, on the importance of data to the core, to the DNA of the company, and also in how Oracle serves its customer, right? The customer trust Oracle with their most precious data, and Oracle is aware of that, and it's providing, right, it's protecting that and providing the right tools to work with that. So the new Oracle mission is that the mission is to help people see data in new ways, discover insights, unlock endless possibilities, right? So there's a big focus on data. And actually, 97% of the Fortune Global 100 companies trust Oracle with their data, right? So the math is simple to do. Out of the top 100 companies in the world, 97 use Oracle database, right? And this goes back in the past. It's a relationship based on trust, and this goes more than 40 years back in the past, right? So the Oracle, the first database, has been developed in 1978. It was a test, right? It was not a commercial product. The version 2 of Oracle, which was the first relational database, was launched in 1979. And since then, Oracle is constantly improving. So the database, it's constantly getting better. It's always on the cutting edge. It's always getting better. It's always getting more secure. It's always incorporating the latest and greatest technologies in data management and protection. And just to show that, right, I saw that Dan also presented the Gartner hype cycles, right? Oracle is always, the database is always following the technologies in the hype cycle, and it's always ready to go there and go in the plateau of productivity or slope of enlightenment, and going and the latest technologies in a matter of technology and data management have been incorporated throughout the years, right, in the Oracle database. All right, so in the early 2000s, there were the document databases and XML stores, right? They were very popular and being like independent data sources. And now you have excellent XML support in the Oracle database. Then there were the JSON, right? There was a JSON, and the document stores was focusing on JSON representation of data. And now you have excellent JSON support in Oracle database, and you can update JSON, you can have binary JSON, you can index JSON, right? So all that capacity have been included in the Oracle database. Actually, the latest version of the Oracle database is 21C. It was actually launched 2 days ago, and it also has blockchain support now. So you can have blockchain tables in the Oracle database. And I find that this fits very well with the lecture given by Dan today. It needs to be understood that this is a private case of blockchain, right? So with Oracle database 21C, you can set up a private blockchain, right? So it's a blockchain technology. It has the same hashing and tamper-proof mechanisms, but of course, it's being a private one, you don't have proof of work based consensus. So the mechanism it's a bit different, a bit simplified, but you still you need to have a small amount of trust in the system, but still you have the system, the mechanism allows zero trusts as in respect with the other players, right? So you can have private blockchain based on the latest Oracle database. So I'm showing here that always, right, as technologies mature and become mainstream and become deployed in production, Oracle has incorporated these in the database, right, as functional features for all the customers, right? And because this is the strategy of Oracle, to provide a converged database, and that is to have just one database version at a certain time, which is able to address all the needs of a customer, right? If you want a data warehouse, right, a database for analytics, or if you want a transactional database, Oracle will fit both roles. If you want to be able to do machine learning, you can do machine learning, right? You have machine learning algorithms, the capacity to run Python for machine learning or R for machine learning. You can do that in the Oracle database. You want to do graph analysis. Oracle has a very powerful graph model and graph analysis engine. You want to do a spatial, right? You want to work with spatial objects, either vectorial, right, or raster. You do have excellent spatial support in Oracle. And all of that with the advantage of just one security model, because no matter what kind of data companies have, data always needs to be protected, right? So the security of Oracle database, that's not negotiable. It doesn't matter what new technologies, right? What new engines, what new data models are added to the database, the technology, the maintenance, the scalability, right? They will always be there on top of everything. So that's the Oracle strategy, to have one convergent, multi-model, multitask, secure, scalable database that customers trust and use. And just to make an analogy, here is the one with a smartphone, right? I mean, in the beginnings, right, in the 90s, there were many gadgets, right? There were non-smart mobile phones, there were pages for messaging, there were digital cameras for photos, there were MP3 players for music, right, and so on. But with the emergence of the smartphone, more or less you have one capable device, and all new functionalities are added to it as apps or modules. It's pretty similar with the Oracle database, right? You will have always the same database with the same security, with the same operation model, with the same scalability, and you will always add new algorithms or new data types or new capabilities to it, right? You want JSON, you have JSON. You want to be able to scale out, right? You have partition databases now, right? You can scale the database geographically. You can scale the database in terms of compute or storage, right? But always just one database. So that's the Oracle strategy regarding this I would say, flagship product. So now we are going to the right to the next question. But what is big data about, right? I've mentioned things like sharding or partitioning in the database, but big data is something else, right? And it is something else. So it's I mean, I'm quite sure you're familiar to it. It started all with at Yahoo with Apache Nudge and all that, but right from a real what it is, it's about volume, right? Large data volumes. It's about variety, data which is very varied, right? It's unstructured, how sometimes it's called. Velocity, it might be that. Data that's coming always is created at a fast pace. And also something that I find very important, that's a value, right? And value is not high, it's actually data with a, let's say, low value density. And there are always some other V's coming over, right? You can put your own V, veracity, right? Data that sometimes is not very trustable. But I would say that volume and value are let's say, the most important, right? So it's and actually I have a Gartner definition, and I have my own simplification of that definition, right? So the Gardner definition is a bit pedantic. It's big data is high volume, high velocity, and or high variety information assets that demand cost-effective, innovative forms of information processing that enable enhanced insight, decision-making, and process automation. And I took the liberty of simplifying this definition a bit and saying, well, big data is the capacity to store and process large volumes of data in a cheap and flexible way, right? Because it's important for it, right? The first applications of big data were processing of personal and user and internet users' data for the purpose of targeted advertising, right? So it was important to be able to find, right, to create profiles of people's behaviors and people's preferences based on their online behavior, and be able to use those as targeted to target advertising, so that if somebody wants to sell dog food, right, you will say, okay, out of all my users as Google, I can identify the people who own dogs, and I can only show the advertisements for dog food to those people and not to everybody, right? So this kind of processing, right, you needed, the amount of data was staggering, and it still is staggering, to identify, right, the behaviors of all people online, but also the value, right? You need to do this kind of analysis, this kind of processing cheap enough so that it's right, you don't spend more to identify a dog owner and serve that person an ad than actually, right, the income you would get from selling that item. So it needed to be high efficiency, high cost effectiveness at scale. That's right, I would say the philosophy and the reason of big data for existing, the base one, right, how it started. And then there is always, that's the what of big data, there's the how of big data, and right, how do you do big data? And that's another question, right? I mean, and you also know the answer to that. It's massively parallel, loosely coupled systems. It's Hadoop. It's having highly redundant commodity hardware, having a simplified platform on top, which offers a simplified development paradigm, right? That simplifies parallel development so that it's fast enough, it's productive enough, it's easy to maintain enough, right? And it allows the development of big data applications which are massively parallel without the classical constraints of parallel programming, right? There was parallel programming before Hadoop, like MPI, but that was incredibly complex to develop and especially to maintain, because I mean the effort of creating a system and developing an application, it's only a small fraction of the effort required to keep it running, to upgrade it, to secure it, and to maintain it, right? So all of these components were getting in the cost, and big data technologies are made to make all these costs be right quite low. And just another thing, what is big data not about? And here, okay, I'm talking about more like the spirit of big data, right? Because now there are more and more technologies which close the gap between big data technologies and standard relational databases and relational data management systems. But right, the application, the core principle of big data, right, it's not about transaction processing, right? So it's not to be able to do transactions which are ACID in nature, right? There are initiatives to go that, but that's not the spirit of it, right? Big data is in spirit to be able to collect large amounts of unstructured data, keep it immutable, and be able to analyze it at scale. Transactionality is not something which is traditionally associated to big data. Also security, right? The initial Hadoop model and initial Hadoop applications were not built with things like personally identifying information in mind, right? They were not built with security in mind. They were not built with data partitioning problems in mind. GDPR was not around at that time, right? So more or less, it's like a big bucket. You put everything in there, like a huge file system, and then you process it as you wish, right? So security was really low, right? Was not in the initial design. Then big data systems are not usually predictable, right? You can't really say that a job, right, will run in the same time, will not run in a predictable manner. So you might have fluctuations because of the natures of this loosely uncoupled systems, right? It's all based on how lucky you are. Also, because of this, right, they're not usually meant for critical applications, right? I mean, yes, if I do a search on Amazon, it's okay if the search engine behind it and the indexing engine behind it uses a big data system. But if I'm paying, right, if I'm doing a bank transaction, I really want to make sure that that transaction has happened once and only once, and nobody else was able to intercept it. And I want my transaction to be done right the next second, because I want to make sure I made the payment and I can take my mind out of it. And also, usually big data systems are not meant for highly specialized recurrent jobs, right? So if I have enterprise data warehouse, let's say for a big bank, and I want the same report to be run daily, right, on data which is always in the same structure, it might be not so efficient to use a big data system, right? Big data systems might lend themselves to this, but because of the nature of the way the systems they are, right, because of the nature of all the coding abstractions on top and the data types which are usually quite generic, right? They can't be really specialized. So if I have a report which is very specialized, which uses very specific data types, and I want it to be run daily and in a, let's say, in a given time frame, I might look at something else to create such a kind of a data warehouse, right? Big data systems are better for exploratory purposes, right? When I do have data, but I still not very sure how it looks, how clean it is, and I just want to explore it. I just want to build something out of this. I want to pioneer something or innovate something based on that. So, right, how does Oracle play here, right? What is the role of Oracle in all of this? And the answer is simple, right? Oracle has been embracing big data from the beginning, right? It's really a complement of the Oracle database. It's not really a fight, right? Because of the nature of the database, which is more, let's say, more transactional, much stronger from an ACID point of view, much more predictable, much more secure, right? And in the paradigm of the convergent database, right, there is place for big data. And Oracle is actually supporting big data technologies. It's actually supporting open source big data technologies. There are multiple ways that Oracle and the Oracle database can leverage big data technologies. There is the capacity to actually integrate an Oracle database with a NoSQL database or with a Hadoop cluster and be able to run queries across, right? So I can have an Oracle database, I can have critical data in it, right? Data which is very sensitive from a GDPR point of view, data which is very fresh, data which needs to be updated, and so on. And have some other data somewhere in a Hadoop store, and have virtual tables on top of the data in the Hadoop store, and actually query those data from Oracle to in that Hadoop store in a very transparent way, right? So I can have an Oracle database and I can integrate it with most of big data technologies out there, and I can access the data from Oracle transparently, and even more, I can have high performance, right? There are Oracle database agents that can be deployed on big data platforms and be able to speed up this query and make them really performant, right? Scale up compute power. And also, more important, I can actually have the Oracle security model on top of big data stores, right? So I can have a HDFS or HBase data store somewhere. Let's say I can have HDFS with lots and lots of JSON files, I can actually impose a virtual table structure on that HDFS store, and I can actually say this in this JSON, this particular field maps to this column, and that's actually a column which is confidential data. So I don't want all users to be able to access that data, right? So anybody querying that data from Oracle will actually be able to access that data, but the certain column, right, as defined by Oracle security policy, would be masked for them, right? So they would not be able to see certain data that exists in Hadoop, right? So I can impose the full security Oracle model of Oracle, right, which is meant for banks and for very strict customers. I can impose it to data stores, to HDFS, even to things like Amazon S3 or Azure Blob or other kind of cloud-based storages. So Oracle database and big data technology, they complement each other very, very well. That's, so I would say, so and big data is part of the Oracle convergent database strategy. And Hadoop, Kafka, various kind of NoSQL technologies, all of these integrate with Oracle, and Oracle can leverage them transparently, having the full Oracle model on top. For example, if I have a dashboard or a business report, which normally was running on Oracle, I can move that data to HDFS, but still use the whole SQL power, right? The whole Oracle SQL on top of that data. I don't need to rewrite any applications if I move from Oracle to big data. I can just use Oracle SQL, which is used throughout the industry. I can just use that and deploy that on top of big data with these kind of technologies. But now we are in the cloud, right? We are in the cloud era, and the cloud came and the cloud changed everything, right? The cloud changed technology in general, changed computing, changed big data, and changed Oracle. So how do you think the cloud changed big data? Well, the cloud changed big data, I would say, irreversibly, right? Because as I simply defined the big data as the capacity to store and process large volumes of data, cheap and flexible, right? Cloud is really operates on that level, right? Because cloud storage is cheap and virtually infinite, and also unstructured, right? I have massive object storages in all the existing clouds, like S3 or Azure Blob, right? So it is cheap to store data in the cloud, much comparably or even cheaper than storing it in any other kind of traditional on-premises big data storage. And from a compute capacity point of view, cloud is highly elastic, right? So I can have, I don't know, 10,000 processor, 10,000 cores, or 1,000 compute nodes working on a job now, and when the job is finished, I can shut all of those down, right? So I have enormous flexibility in matters of compute resources in the cloud. So, and again, right, this is a commercial factor, right? This is a financial factor. When you have cheap storage like that level of price point, and you have cheap elastic compute, right? You need to shift your paradigm, because Hadoop and big data in general, right? It was based with collocating storage and storage and compute, right? With scaling storage and compute together with a certain architecture which was a bit rigid, right? And all in order to increase redundancy and maximize network efficiency. But with the economical changes brought by the cloud, this pretty much changed the way big data works, right? So now the prevalent model in big data in the cloud is that I'm having a cloud-based object store to just store data all together, because it's very cheap to keep it there, no compute attached. And when I have a need, right, when I do want to run a particular data, when I want to build a particular index, when I want to do a particular analysis, I just create a virtual cluster as large as I want. I process the data on that cluster. I save the result back. and then I shut it down, right? And I only have to pay for the number of processor hours, or the CPU hours that virtual cluster was up. So big data is quite mainstream now in all cloud providers, and we're right at the next point. And the next point is actually to make it as simple as possible to integrate in enterprise application and processes, right? It's there, it's mainstream. Now we need to find a way to use it in the most efficient way and the most business, the way that actually helps business and creates results. And I'm going now to talk to you about how Oracle has the cloud has changed Oracle, right? And Oracle has had a late-ish start in the cloud, right? There was an Oracle cloud infrastructure generation 1, which was in the first line, was so structurally similar to how Amazon works now, and that wasn't really something that was successful. So now we are at the second generation of cloud, right? We call this the Oracle Cloud Infrastructure, and it's a cloud built specifically for enterprises, right? It's the first generation of cloud was a consumer cloud, right? It was focused on elasticity, on paying just for what you use, on scale, and of ease of use, right? But it was lacking on things such as security or integration or enterprise support. So this is what the second generation of Oracle Cloud Infrastructure brings, right? It's a cloud built for performance and for security and for enterprise customers, right? The Fortune 100 we're talking about in the beginning. And to just show so to say just an image, there are currently 29 Oracle Cloud regions, we call them. We don't call them data centers. And the reason we don't call these data centers is that within a region, there are more data centers. So a region is normally consisting of 3 data centers, which are around 60 kilometers apart for high availability and redundancy, right? So there are currently 29 Oracle Cloud regions all over the world. In Europe, we have one in Zurich, one in Frankfurt, Amsterdam, London, and also France and Italy are in the process of being built. All right, so Oracle has a cloud, right? But what does that mean for the Oracle database? And the answer is, well, it's actually a great development, because Oracle database was already a very good system, right? A very good piece of software, but everybody knew that it was quite complex to operate, right? There were specific people that were doing just that, were the database administrators, right? That were always looking at the database, always managing the database, always upgrading, patching, looking over the index, tuning it, optimizing it, securing it, always being, on the lookout if there is not a security patch that they need to apply right away, and so on. So from an operations perspective, Oracle databases required quite a lot of attention, and there were a lot of, let's say, automatic, right, a lot of manual work, ungrateful work associated to maintaining an Oracle database. And the cloud allowed, right, the proliferation of autonomous systems. So in the cloud, right, I can have the scale to have a framework of automatic management, right, of Oracle databases. So using the cloud development and using the cloud fabric, we can actually automate the Oracle databases, so they now are more or less, you just provision it and it just runs, right? So we are using the cloud infrastructure with the Oracle database, and we're having a layer of automation on top, which fully automates all aspects of operation of the database. And that for our customers is a very, very, very big deal. And the reasons for that, it's from a complexity point of view, it's much easier, right? They don't need to plan complex upgrade cycles, right? From a security point of view, they can know that once a security patch is released, it is applied automatically by the system, right? They are not exposed because they don't apply the patches in time. From a availability point of view, we guarantee 4 nines availability, right? So it's 99.995 available. That means there are just a couple of minutes, a few minutes, 5 minutes of downtime per year in these SLAs, right? So it is always on, it is always secure, and it works. And further on, right, it has all the operational advantages of the cloud, right? So if I want more compute power, I can elastically increase it to 100 CPUs. I want less, I can decrease it. I want more storage, I can increase the storage. I need less storage, I can decrease the storage. And all of this is happening online, right, with the system hot, no downtime. And right, the billing, the customers pay per second, because that's something that, right, customers only look at. How much does it cost? With this, they can actually optimize by second how they are built. And further on, there is actually an auto-scaling capability, right? So if they can always pick a baseline, they can always say increase automatically the number of processors allocated to the database if needed, and then decrease it back again. And the automation framework in the background will do just that for them. So this is, right, the big change that the cloud brings, right? It brings autonomy, right? You have less to set up, you have less to maintain, you have less to configure, you have less to optimize. You have just a system, you just tell it, I want a database and I want a VM, and it will create, maintain it, upgrade it, secure it for you. And when talking, right, when talking about big data, right, because, right, you can make this database very big, right? You can make it like 1,000 processors, and you can assign to it hundreds of terabytes of storage. But it will be a database, right? It will have the cost of a database, and it will be, let's say, there are applications where you still need things like Kafka or things like Spark. There are applications which make sense to apply open source big data technologies and not run them on an Oracle database. And this is why in the cloud, we build a complete platform, a complete data platform, which is built around the Oracle database. All right, so if you look at here, right, this looks like a data pipeline. Data flows from the left to the right. And in the Oracle cloud, there is a streaming service, which is Kafka compatible, right? So you can run your Kafka streams on the Oracle cloud. You have a data integration which uses Kafka, right? You can integrate your Kafka stream with your Oracle database. You can just flow data from Kafka to Oracle. You have a data flow service, which is serverless Spark, right? So you can run your Spark jobs in the cloud. You can just submit your jar or your PI file and say, I want to run this job on this version of Spark, and I want to have 100 nodes with 24 processors each. And you will have the infrastructure created for you, all secure. It will run the job, and then it will gracefully shut down, and you'll only retrieve the results, right? And you also have managed Cloudera, right? You can also run Cloudera Hadoop on the Oracle infrastructure, and you've got also all the integration technologies, right, to integrate this with the Oracle database. So you can have a big data, right, a Cloudera Hadoop cluster, and using the SQL and Hadoop capacities I was showing earlier, you can actually execute queries across Oracle and Hadoop. Also, very soon, right, there is also an object storage, which is not featured here, but you can also execute Oracle SQL on top of object storage. And you can also integrate with other clouds. So you can have data in Azure or in Amazon in their object storages, and you can query that with the Oracle database using full power Oracle SQL. And right here, we are going a bit towards the data mesh capacities, right? You can have data lakes, and a data lake would be an object storage or a big data Hadoop, if you want to play that way, or even a very large database, or or NoSQL cluster, right? And you can have multiple of those, and you can interconnect them in a data mesh strategy. But in that perspective, you will have a right. You need to know what data you have, where you have it, and where the data comes from. So this is why there is a need, right, in modern cloud applications and modern cloud architecture, there is a need of a centralized data catalog. And that's what you also provide in Oracle Cloud Infrastructure, a data catalog service. And this acts as a central repository where you can index, catalog, annotate, describe, and access, right, data that you hold in all these underlying storages, right? So data can be in streaming, data can be in Hadoop, data can be in Oracle database or in multiple Oracle database, but you'd have just one way, right? Just one repository where you can find that data and connect to it using this data catalog, right? And on top of the data catalog, you've got the actual analyst or data scientist or developer facing services. And here there is things like an analytics service, right, for building dashboards, for doing citizen development, right, kind of visual interactive analytics to actually see the data, navigate through the data, and be able to just use, right, use a no-code rich interface to visualize and interact with the data. There is a data science service for developing rich applications, right, rich machine learning applications. And there are also various other integration points, right, for complex application development. So in a nutshell, this is how the complete data platform services of Oracle looks like, right? It's built around the Oracle database, but with all these tools, and most of these tools, or a lot of these services, are actually based on open source services. So there is a support for open source Kafka. There is support for Spark. There is support for Cloudera Hadoop. The data science service is based on Python, and you can use, right, it's Python 3, and you can use all open source Python packages from that you normally install with pip. It also even supports Conda environments, right? So there is a lot of open managed, right? But all of these are managed by the infrastructure, right? You don't have to set up a complex Python environment, and in order to scale it out, you don't have to worry about it. It's the Oracle Cloud Infrastructure building that for you, right? You just say that you want a notebook or running on this kind of machine with 2 GPUs attached, and you've got it, and you'll just connect to it. So that's how the big picture looks. Now, just for a couple of case studies, I've just handpicked 3 of them. One of them is PaySafe. It's actually a Bulgarian company, and it's specialized in detecting fraud. So it's working with major payment operators all over the world, and it's doing fraud analysis, right? So it's using graph technologies massively. It's integrating with the various platforms, various data platforms of payment operators, ingests payment transactions data, models that, and then explores it to find abnormal behaviors, to find outliers, and to try to identify fraudulent cases. And it's using that, right? It's doing that using Oracle Cloud Infrastructure. It's using the Oracle database, and it's using all those services I've shown you to model the data as a graph, to analyze the graph, to explore these huge graphs of millions of vertices of links per day, and then, right, to provide the right insights and to identify the transactions which are deemed to be fraudulent. Another one is DX Marketing. This is a very nice company. It's a relatively small company based in the States. What they do, they offer specialized digital marketing services to their customers, right? So what they do have, they have an American company. So from a GDPR point of view, they can do much more things with customer data. They have their own proprietary list of people. They have tens of millions of profiles of people living in the United States in their proprietary database, which runs on Oracle. And when then specific customers come to them, right, companies, and say, I want to target this kind of demographics. I want to reach people living in this area, having this kind of profile with this kind of advertisements, right? And what they do, they use Oracle Cloud Infrastructure to connect to all the data sources from their customer companies, to ingest their data, to link that data with the customer profile of US citizens which they already have, and to identify, right, to pinpoint the right people to be targeted with very precise marketing campaigns. And they do that using Oracle database and Oracle Big Data technologies in the cloud. And finally, my favorite, actually, I love this this story. I can share with you the bigger story if you like. It's AgroScout, and what they do, they do precision agriculture. So they offer their services to large farms and large agricultural companies. They fly drones or across cultures, right, across agricultural fields, and they identify problems like pests or like drought or like bad soil or like contaminations using the drones, using computer vision, right? So they use drones to identify problems in crops, and then recommend very targeted actions and this way the companies can use pesticides, right? Or can they act only in a specific area in a crop where there is a problem and not spray all around. So this is from environment perspective, from efficiency perspective, this is great. They use technology to improve agriculture and to provide targeted agricultural actions. Okay, so I think I went through it quite fast, but I was aware of the time, and also I was hoping that we still have a couple of minutes to give you a live hands-on feeling of what Oracle Cloud looks like. Are there any questions so far?
I think Edward wanted to ask some question, if I'm not wrong. Edward?
Yes, Professor. I've listened to Andu, and I was hoping to ask him at the end of his presentation, but I can ask him now. Can you hear me, Andu?
Perfect. Hi, Edward.
Okay. Hi, nice to meet you, and thank you for this presentation and your time. I was hoping if you can share with us how did you manage to work in Oracle, and if you had any previous experiences in this domain before working in Oracle, or how did you find out that you like working with big data? Or
well, I think I was very lucky, and I also met Dan. So so being lucky and knowing Dan is the right combination, and then yes, studying. I can come back to that later.
Sure.
But and actually I'll give you a few tips on how to start seeing if you like to work with Oracle, with big data, and with other kind of technologies in general. And that is right. We do have at Oracle a free trials program, right? So basically how it works, there is a link. I'll also share it with you. You go to oracle.com cloud free, right? You click it. The program is explained there. So you will need to register, put your data. It will ask for a valid credit card. You will not be charged, so no money will be taken from your account at all. But a credit card is required because right, we want to make sure that you're doing just one trial. You're doing it just once. So this is why you do need a credit card for validation. But apart from that, you will get an account. That account will be valid for 30 days, and you will have $300 to test. And believe me, you can do a lot with $300. So you can have your databases, your compute VMs, right? You can test out a lot of technology in that budget. And at the end of the 30 days, the account will not go away. You'll always have the option, of course, to convert it into a paying account if that is what you want. But even if you don't do that, you will have what's called an always free tier, right? So there is a list of services, like a couple of virtual machines, a couple of very small databases, a load balancer, and so on, right? There are a couple of services which are included in this always free tier. So even after the account is outside the trial period, you will still have access to Oracle autonomous databases. You will still have some micro VMs, right? You'll still be able to, let's say, have a working database, have a development environment, have a couple of UIs, have very, let's say, testing applications. They will always be around, right? And they will never expire. So that's that is always free is about. It is great, right? You can have a functional Oracle database with full features in this always free. And apart from that, there is a very nice portal. It doesn't have a short link, or I don't have it, but it looks like that. I will share it with you. It's public, and it's called Oracle Live Labs. And in there are tens of workshops, which are very nicely explained. They contain right, and they touch big data, they touch database management, they touch application development, they touch security, they touch all these features and all these topics around Oracle and data management. And you can run most of this on the free trial accounts. And even more so, some of them, and I think that's also marked, right? Some of them are actually made specifically to also run on the free tier. So even if you're not within the grace period of your account, right? You can still use those free tier resources in there to run your labs. So, and as I said, and it's constantly updated, and it's a very nice portal. And now, I think the time is quite right. I will do my best, and please let me know if you can see my browser. You should be able to see my browser, right?
Just the screensaver, Andu.
Just the screensaver, because I need to explicitly share. Because I need to explicitly share the. Where are you?
The browser screen.
Yes. Share tray again. Desktop window. And share. Okay. Tell me when you can see my browser.
Yes, we see
Perfect.
the Cloud Console, yeah.
So now, actually, I'm going from the beginning. Let's see if it works. This is how it looks like when you, so you will write in cloud.oracle.com, right? And the first thing you will be asked for your cloud account name. Sometimes we call it this a tenancy, right? This is something that's unique to your cloud account. Mine is called Aura SC Alps, Oracle Solution Engineer Alps. This is my line of business where I'm located. And then I will click next, and I will have to sign in. I will choose a federated user, right? And in my case, actually, I will use the Oracle SSO, right? So this, you can also have a username and password, and that's what you're going to use in your free account. I will actually have an account which is integrated with my Oracle identity, with my Oracle global identity. And I have a two-factor, most likely, unless, yes, I'm giving you the full, the let's say, realistic experience here. I need to find my phone, just a second. So normally I would be in a VPN and I would not need a two-factor authentication. but I tried it and that does not work with Zoom. So I need to be outside the VPN. So I need a two-factor. And sorry. It's all about that's in the industry that's called the demo effect. And also, yeah, because being in and out the VPN.
Yeah, you cannot use the single sign-on.
Exactly, but now it's it was okay. It was just some dirty cache. Okay, so I'm logged in, right? This is how the Oracle Cloud Console looks like. As you can see, right, this is my home region. It's Frankfurt, right? So first thing, if I, let's say, by default, all the services I'm creating, right? If I'm storing some data, or if I'm creating a database or a VM node, they would be in Frankfurt. From here, I can actually select, right? If I want in Brazil, if I want something exotic, or United Kingdom, or in the States, right? So from here, I can choose where I want to create my services. And here, right, in this hamburger bar, I actually have access to my various type of cloud services. So I have core infrastructure services. This means compute, right? Compute nodes. They can be VMs or they can be bare metal, dedicated servers just for me. Or block storage, which is storage which I attach to a VM or a bare metal instance. Or object storage, right? Or file storage or networking, right? Because I can create full environments in the cloud, so I can create virtual networks with virtual policies, subnets, and so on. And then I have my Oracle database services, right? And I have autonomous data warehouse, autonomous JSON database, autonomous transaction processing, then dedicated special kind of Oracle database deployments, and clouded customer if I have, right, a database deployed somewhere in my data center. And then MySQL database, which is again, right, we have MySQL and we also have a MySQL cloud service and NoSQL database. Then Apex development, and then I have the data and AI services. And here I have the big data services, right, the Cloudera Hadoop, digital assistant, chatbot, data catalog, which I was just mentioning, right, that layer which holds metadata of all my data, no matter where they are, in the data lake or in the database. Data flow, which is Spark as a service. Data integration, service connector hub, this is an interconnection tool, and data science, right, for building complex data science applications on Python stack. And then, right, analytics, a resource manager for stacks, right, this one is based on Terraform, email delivery, right, if I want to have emails sent when the various things happen, the blockchain platform, VMware, and then, right, some security management and so on. So this is how it looks like. I think the data science might be interesting for you. So I'm going just into that. Or first of all, let's see how the databases look like, right? I'm clicking here, right? And I can see the kind of databases I have, right? So this is a data, I have two databases. This one it's running, this one is stopped, right? I can click on it. I can see details about the service. I can get a connection for it, right? And I can use the details provided here to connect with a third-party tool. I can even go to it. I can scale it up or down, right? I can say, okay, I want to have I want to have 40 CPUs, right? 40 processors, because I have a big load. I have something coming up, and also I want more storage attached, and it will happen, right? Not doing that right now. I was just wanting to show how a particular database would look like. But let's look at the data science to a service, because that's usually something that creates a lot of interest, right? And when I go to data science, all my data science work is grouped into projects, right? And the project is where I keep my models, right? My data science models and my notebooks. And for example, right, so this is what a project is. Some notebooks where people work collaboratively, data scientists, and some models which are outputs of these notebooks. And I can create a new notebook if I want. I can say, I want it to be called, I don't know, a machine learning notebook 1, notebook 2. And for the infrastructure, I want, let's say, I want to run it on a machine. The last digit means the number of cores, right, of processor cores from the VM. So I can have VMs which have 24 cores, right, 24 quite big one, I would say, or even GPUs, right. In this my allowance, right, I can only have
GPU, graphic processor units, those very powerful processors.
Exactly, but normally we have machines which have up to 16 GPUs attached, so gigantic, really big. But of course, there is very tight governance on all of this. So I can only create machines with 1 GPU. Again, these are quite powerful, right? These are big toys. These are, if I'm not mistaken, these are Volta, right? These are NVIDIA Volta V100 GPUs. So the latest generation of of industry standard GPUs. Of course, I'm having a cloud admin who is not my tenancy; it's the tenancy of the team, and they tell me what I'm aware about, when I'm allowed to create GPUs or not. And GPUs are quite expensive, so they most likely they will ask me why I created one. But in order, right, just to make an idea, somebody can actually look in this. There is, right, a quota service. I can see how many GPUs I can create and what type of GPUs I can create. I'm allowed to create. And if I go to data science, right, I can see that I actually can only create GPU 1, which I'm not sure where they are. So GPU 2 0 and GPU 1. For some reason it's not here, but I might be I'm allowed to create. So all of this, right, is controlled by my admin. But going back, right, this was just a small evaluation. Right, going back, I have a project, and in the project I have a notebook. Right, I can this notebook is currently active, right? I can open it. And if you're familiar with it, you've recognized the Jupyter Lab logo, right? So it's basically a Jupyter environment. I have exactly for Python. It's quite convenient. I have a nice. I do have access to the local file system of the machine, right? I can attach storage to that machine. I do have a file browser. I do have a terminal, right? So if I want to run various kind of shell commands on the node, I can do that, right? I have access to a bash terminal. I can do a pip install, right? Just to show that it works, right? I do have to access to the to a terminal, and for example, I can launch a Python notebook, or I can launch a Python console, and I also have some examples, and these examples are quite nicely put together, right? So I can go here, I can see what, right, and for example, classification wine, it has wine in it, why not? Load example. and it will be quite a rich notebook. Right, so it's nicely explained. It explains what it wants to do, right? What is the purpose, and then it will explain. There will be the blocks of code. I can run them one by one, right? And the example will I mean, basically, I can just follow the notebook. That's the nice things about notebook. They're self-explained. If a notebook is nicely written, right, it contains it's self-documented, right? You can just read through it and see what the code in there does, and in the end, you end up with a very nice and comprehensive document, right? In the end, it will look like a document, right? I've got, for example, some already some features identified and the data types of them, and I'm already using some data frame operations in pandas, and there is also some built-in. I mean, all of this uses open source Python, but there are some built-in helper libraries, for example, like this nice plotting features and so on. All right, so you can just go in there and start playing around and understanding, right, and having explanations for all of this. And if you want to go to the next level, then it's this other link I'll provide you, which is the Oracle Live Labs, right? And here you have Live Labs workshops, that is, for all topics, right? From hybrid architectures, autonomous database. I mean, all of these, each one of these is a self-contained workshop, which will, in your own pace, you'll have a document, you'll understand what's the purpose of it. It will tell you what resources you need and how to get it. And also, there is a category of workshops which is always free, right? So when your account has expired and you only have access to all these free resources, these workshops are guaranteed to also work on an always free account, or on those services from a free trial account which remain active through, an indefinite period. And how it looks like, basically you launch and you'll have an outline. It will explain you what the purpose of the workshop is. You'll have details. Then you'll have to say launch using a free trial workshop, and it will explain you all the steps, right? How do you get the workshop, the free trial account, what you need to do, what you need to provision, and so on. That's, I think, we're oh la la, we're already now. I finally seen the time, so I'm
yeah, but anyway, it was very interesting. Okay, maybe we can collect more questions, if any, from the audience. Guys, do you have any questions?
And please apologize. I do have time. I'm still available, but I wasn't sure. I had the impression it's just one digit over the hour.
It was very interesting indeed. Okay, so I guess there are no more questions so far. Maybe people will take some time to think it over. Maybe they will address questions through email or to me, and then I'll convey to you. Anyway, Andu, thank you very much for this nice presentation. It was a good refresher on what Oracle is doing these days, and I like very much the architecture image you showed us, including everything, including streams, including different types of data stores. Even I saw Parquet over there. Cloudera is there, Kafka, all the things that are so interesting in big data right now. So thanks a lot again very much, and hopefully we'll see you again sometimes in the future in our lectures.
Dan, many thanks. Thank you so much for inviting me, and yeah, the pleasure was all mine.